Assalamualaikum sir. My name is Muhammad Aqib bin F1097. My registration number is 01DEE 21F1097 and I am from class DEE 3D.
Assalamualaikum, my name is Muhammad Nur Amin bin Abu Bakar. I'm from DE3D. My registration number 01DE21F1110. Today I want to present about power plant waste. And next, two eco-friendly method to treat power plant waste. Firstly, we have flow gas desulfurization, FGD. So next, I want to explain about flue gas desulfurization or FGD. Flue gas desulfurization is the process of removing sulfur compound from the exhaust emission of fossil fuel power station. It is done through the addition of adsorbent, which can remove up to 95% of the sulfur dioxide from the flue gas. The term flue gas desulfurization has traditionally referred to wet scrubber that remove sulfur dioxide (SO2) emission from large electric utility boiler, mainly coal combustion, and it also used to reduce SO2 emission from process plant such as smelters, acid plant, refiners, pulp and paper mill. Term FGD, acid gas or acid rain control are used categorize a wide variety of control system design. So now I want to explain about block diagram of FGD. The present are anywhere from 1% to 10% of sulfur in pulverized coal burned by electric power generation plants produced in the flue gas high concentration of sulfur dioxide SO2, a gas which, if left untreated in the atmosphere, produce acid rain. Flue gas desulfurization FGD using powderized trona sodium sesquicarbonate in dry solvent desulfurization system has gained widespread acceptance. Trona react with SO2 to produce dry reaction product that are then removed either in dust collector or electrostatic dust precipitator (ESP). The reaction efficiency depends upon, among other factors, the particle size distribution of the trona being react. Osokawa produced complete trona grinding system using air classifying mills, which are being successfully used with proven effectiveness around the world. So next we have flowchart for the FGD. Firstly, we have WHB, flue gas from incinerator go to WHB, BFW also go to WHB, and steam go out. And then WHB go to the blower, and blower go to the gas exchanger and blow out the clean flue gas to stack. And then gas exchanger go to SO2 absorber, gas flue gas in, and then SO2 absorber go back to gas exchanger, clean flue gas out, and then seawater pump into the SO2 absorber, and power also into seawater pump, and seawater into seawater pump also, and power into blower. And yeah, that's all for the flow chart we have see in this picture.
Next for the method number 2, which is electrostatic precipitators or ASP. Okay, electrostatic precipitators. ASP is a filterless device that removes fine particles like dust and smoke from a flowing gas using the force of an induced electrostatic charge minimally impeding the flow of gases through the unit. Electrostatic precipitators are used in steam plants for removing the dust from flue gases. Besides, ASP used to remove the bacteria and fungus in the medical field. Okay, this function was reduce air pollution and can recover metal oxides from the stack. ASP also can collect wide range of particle size and they can collect particles in dry and wet states. Every particle has been given a charge and negatively charged particle migrate to the grounded collection plate and be captured. Okay, then we move to the block diagram of ASP. Okay, as we can see here, this is my block diagram for the ASP process. Okay, first, the flue gas from boiler, it will flow to the dust collector by electrostatic precipitators. Then, the gas will flow into waste, which is the gas will flow to the dry ash and continue flow to the silo. Okay, the gas that released from silo will use to another plant, and the gas that from dust collector by electrostatic precipitators will flow to another waste, which is FGD or flow gas desulfurization. At the FGD, the sulfur dioxide gas will be removed and it will flow to the clean flue gas. When the gas was fixed from the sulfur dioxide, the gas will collected in stack and it will remove to the environment. Okay, for the last one, we move to the another block diagram of electrostatic precipitators. Okay, as we can see here, we put the another of block diagram for ASP. Okay, electrode wires produce a corona that release electrons. These electrons attach to dust particles and give them a net negative charge. Grounded collecting plates attract negatively charged dust particles. Then, the dust particles are removed from air. A spray of water or lime is generated in the scrubber and exhaust in pass through the spray. Scrubber remove gases like sulfur dioxide from air. Dust polluting gases like sulfur dioxide are removed from air. Okay, I think that's all from us for the effective assessment 2 for subject power system. Okay, thank you.